Good morning, everybody. This is a video on learning how to graph absolute value functions. For each of the graphs we create, we're going to have to be sure to include 4 items. So for each graph, we're going to be including the domain, the range, we're going to be stating the transformation, and then finally we'll have to write the rule using what's called coordinate notation. I'll be giving you 6 examples, and there'll be 10 of them for your homework. We're starting with what's called the mother graph. It's called the mother graph because all the graphs that we'll be doing will resemble this graph very, very well. Many books call this the parent graph, but we'll refer to it as the mother graph most of the time. Remember that f of x is the same thing as y, so we could have written y equals absolute value of x. Notice on the chart I've created it says x and then y. We could write x and then f of x, but I'll just keep the x and y there. All of these graphs have a place where they are at what's called their minimum. Can you see that the smallest y value we can possibly get is 0? Because when we take the absolute value of any number, don't we end up getting a number that's positive? Or at the very smallest, we could actually get 0. So what input value for x will cause the output value to be 0? Well, the answer hopefully is clear. It's 0, right? Because the absolute value of 0 is 0. So that means I'm going to put 0 in the center of my xy chart. I want it to be in the center. And the absolute value of 0 is 0, so therefore, I already know that this graph must go through the origin. I'm going to put my first blue dot there. I want to see what's happening to the right and left of this point. So now I'm going to plug in 1 and 2, because I want 5 points to be listed. I'm plugging in 1 and 2, and now I'm going to evenly space go down from 0 to -1 and -2. These output values will happen very, very quickly. When I plug in 1 here, the absolute value of 1 is 1, and the absolute value of 2 is also 2. When I plug in -1 for x, notice the absolute value of -1 is +1. And the absolute value of -2, I'm plugging in -2 for x, is +2. So now I know my 5 points. Be very careful as you plot these points. 1, 1 is here, 2, 2 is here, and notice it appears that the slope is +1 on this side. I have 2 more points to plot. -1, 1 is here, and -2, 2 is about there. Your graphs will look a little bit better because you'll have graph paper. You'll also have a ruler. So I'm not going to be using a ruler just to help speed things up a little bit, but you'll grab your ruler and you'll draw in a ray going this way, and you'll draw in a ray going this way, and make sure you include arrows to note that this graph goes forever in both directions. That helps to understand domain and range better. So the graph itself is complete. Notice it changes from decreasing to increasing at the special point called the vertex. This is the vertex. It's where this graph is at its minimum. The domain of the graph is all of its input values. This graph goes forever to the right and forever to the left. So the domain will be all real numbers. We can input whatever we want for x, so we're going to use that script R that we've talked about before. The range isn't all real numbers because notice the graph never goes negative. This graph is positive, yes? So I'm going to say the y values must be greater than or equal to 0. I also could have said f of x is greater than or equal to 0. I have no real preference. It kind of depends on the way the problem comes. But since it says f of x here, I would probably say yes. But these two things mean the same thing. Now, the last 2 items kind of don't have merit on this first problem because we haven't translated this graph. There is no translation. And writing coordinate notation is kind of silly on this problem too. So I put NA for both of those. You'll see what those will look like on the next examples. The next examples are going to go a little bit faster. Okay, let's move on to example 2. The graph looks a little bit different now, right? We don't just have x inside, so some sort of transformation has taken place. We're wanting to find this middle point first. We're trying to see what number I can plug in for x that will make the absolute value portion equal to 0. Can you see if I plugged in 5 for x, I would have 5 minus 5, that would give us 0, right? So 5 is that perfect number to go in the middle. That's the middle number that we need for our graph. So I'm going to go up, and I'm going to go down. And do you see how easy it is to choose the 5 points to graph? So now I'll plug those in one at a time. 5 minus 5 is 0. The absolute value of 0 is 0. If I plug in 6, 6 minus 5 is 1. And the absolute value of 1 is 1. And the funny thing is, if I plug in 4, I'm going to get 1 also. Because 4 minus 5 is negative 1. And isn't the absolute value of negative 1 equal to 1? So these output values match. Guess what? These two output values are going to match too. Because 7 minus 5 is 2, and the absolute value of that number is 2. So likewise, I'll get a 2 on the bottom. The output values will come very quickly as long as you choose your first 5 points correctly. That's the most important part. So let's graph now 5, 0, 1, 2, 3, 4, 5. The point 6, 1 is here. 4, 1 is here. 7, 2 is here. And 3, 2 is about there. So you can see that V shape happening again, yes? So I include my array this way. Include my array this way, and that's a pretty good graph. Yours will look even better, of course, because you're using graph paper. So domain, all the way across the x-axis, so we have all real numbers again. The range appears to be the same as well. All the y values have to be greater than or equal to 0. So now the new stuff. Translation, what do I put? What has happened from this graph to this graph? Aren't the graphs identical except it's 5 units to the right? So for translation, I'm just going to put right 5. You're literally just putting into words what's happening. Finally, coordinate notation. We're going to write what's happening to the coordinates, comparing these coordinates to these coordinates. All of the x values are 5 bigger. So therefore, x plus 5. All the x coordinates are 5 bigger. The y values are exactly the same, and so I'm just going to put a y in there. So this is the coordinate notation that says, hey, we're sliding 5 units to the right. It doesn't look like it when you look at the equation, but we know that we're sliding 5 units to the right. This is called a horizontal translation. Okay, next example is even faster. Scooting to example 3. Looks like we have another horizontal translation. My middle number has to be the x value that causes this absolute value to be equal to 0. So negative 2 is my middle number this time. Negative 2. So I'm going to go up, and I'm going to go down. And now my output values I should be very comfortable with. If I plug in negative 2, negative 2 plus 2 is 0. Notice the 0 coming out in the middle again, just like the other examples. So I predict the 1 here and here, and a 2 here and here. And so now the graph goes to negative 2, 0, these 2 points, these 2 points, and of course the exact same V has taken shape, but just at a different spot. The vertex is clearly different. The domain is still all real numbers. The range, still f of x greater than or equal to 0. The translation is left 2. And the coordinate notation, we're going to the left, so this is x minus 2, and the y values are not changing. So notice I've included all 4 important pieces of information. All right, example 4. Notice inside the absolute values, we just have x this time. So this equation looks a little bit different than the 2 that we just did. So our middle number I've already put down, 0 is what causes the absolute value to be at its minimum. So 0 is back to being in the middle of our chart again. And if I plug in 0 here, our output value isn't 0, it's 0 plus 5. So here for the first time, our y values are changing. If I plug in either 1 or -1, it's quick to see that we'll get 6. And if I plugged in either 2 or -2, it's also quick to see that we'll get 7. And so now I have to be careful here. 0, 5 is up here. And the remaining 4 points are going to be here and here and here and here. And now once again, that familiar V shape is taking place. Okay, so the graph goes pretty quickly as long as you get those 5 x values correct. Domain, all real numbers. Again, range isn't the same this time because notice this graph has been raised upwards, right? So this time our f of x values, our y values have to be greater than or equal to 5. 5 is the smallest we get. All the others are bigger than that. Let's see, putting translation into words. We haven't gone left or right. What's the only thing that we've done? Up 5. So I literally am just putting the words down. Up 5. That shows the teacher that you understand the translation, what's happening. For the coordinate notation, the x's aren't changing, so I'm just putting x, comma. But if the y values are all 5 bigger, doesn't that mean my y coordinates are going to have to be a y plus 5? Okay, so hopefully you're noticing some patterns here. Math is a lot about patterns, and we're making some of those patterns clear while also reviewing domain and range. So this is very good for you. All right, 2 more. We're going to speed through them, and then we'll finish this up. All right, to make the absolute value portion of the graph, can you see 0 is the perfect number? Okay? When I plugged in 0, 0 minus 3 gives us -3. And now I have to choose my symmetric points again on either side. So I'm going to go up 1, 2, down -1, -2. And as I plug these two values in, I must get matching y values. 1 minus 3 is -2 for both of those. And if I plug in 2 or -2, I should end up getting -1. So there are my 5 points. 0, -3 is here. 1, -2 is here. -1, -2 is there. 2, -1 is there. -2, -1 is there. And oh, I can hardly believe it. We got another V. Domain, all real numbers. Again, you might ask yourself, is the domain always going to be all real numbers? The answer is no if you're in IM4 or pre-calculus, but in the course that you're taking, the domain will always be all real numbers for absolute value functions. The range. The y values are all greater than or equal to -3 this time. The translation in words, this is where you're giving words, all I'm writing is down 3. And for the coordinate notation, the x values haven't changed, but the y values sure have. The y values have been moved down 3, so there is the coordinate notation. All right, are you ready for the last problem? Because we've got to blend both of these ideas together, finally. In other words, in our last equation, it looks like there's been a slide left-right. And it looks like there's been a slide either up or down. So there's 2 translations happening on our last example. Okay, so this is what we want to be able to get to. So, for our middle number, the most important thing to get off to a good start, what value of x makes this part of the equation equal to 0? Ask yourself, what number plus 8 gives me 0? That number is -8. So -8 goes in the middle. If you don't choose that number correctly, So now I'm going to go up from -8. That's -7, -6, and then -9 and -10. So notice I didn't put any tick marks here. I wanted to kind of be some suspense as to where this graph is going to be going. I'm going to be going left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This graph is really far to the left. When I plug in -8, this becomes 0, and 0 minus 2 is -2. -2. So, this is a tricky one. To the left, 8, and down 2. So there is our vertex. If I plug in either of these two numbers, the graph is going to elevate by 1. Let's check that out. -7 plus 8 is 1. Absolute value of 1 is 1. And 1 minus 2 is -1. So we have -1 here and here. And to find our last 2 points, I can plug in -6. -6 plus 8 is 2. Absolute value of 2 is 2. And 2 minus 2 is 0. So there are our 5 points. The graph here is kind of butting into the chart here. I'm sorry for that. But you will get the idea that if I go up and to the right 1, and up and to the right 1 again, and left the same way, we get the V shape happening yet again. Make sure you put the arrows on. So this graph still has a domain of all real numbers. Can you see what the range is? The range is just from -2 upwards. So that is f of x is greater than or equal to -2. The translation, you need to give me both translations for full credit here. We're going left 8, left 8. And we're also going down 2. So this is our only one that has 2 translations, excuse me. Finally, the coordinate notation. We're using parentheses to show coordinate notation. Since we're sliding 8 units to the left, I have x minus 8. And since we're going down 2 units, I have y minus 2. So I think these 6 examples are as close to perfect as they can be. Model using them, and I wish you luck on your assignment.